our universe, a truly vast expanse, full of shimmering galaxies, burning stars, and countless planets, an incredible tapestry of wonders and deep mysteries. It certainly seems like an immense, undeniable something, a grand cosmic stage teeming with existence. But what if I told you something truly astonishing? A concept that might shake your understanding. What if, on the grandest scale imaginable, the entire universe actually adds up to absolutely nothing? Zero. Zilch. Nada. This is the mind-bending core of the zero-energy universe theory. It sounds completely counterintuitive, I know. I get it. How can all this incredible equal nothing at all? Think of it like a giant cosmic balance sheet. Positive energy, represented by all matter and radiation, is perfectly, exquisitely offset by negative energy. The pervasive, attractive negative energy of gravity. Everything held in a delicate, perfect equilibrium. A cosmic balancing act on an unimaginable scale. Now, this isn't just some philosophical flight of fancy. It's a serious, testable idea in modern cosmology. Physicists around the world ponder this very possibility. This intriguing concept stems from fundamental physical principles. Laws we believe govern everything in existence, like the bedrock principle of the conservation of energy. A law that dictates the rules of the game, from the smallest subatomic particle to the largest galactic supercluster. Could the universe itself obey this ultimate, elegant rule of nothing gained, nothing lost? So, I invite you to join me on an extraordinary journey. A journey deep into this mind-bending, perspective-shifting concept. We'll explore the fascinating possibility that something so vast, so seemingly full of incredible substance and energy, could fundamentally, incredibly be nothing at all. From its mysterious, fiery birth in the primordial Big Bang, to its ultimate, currently unknown, and perhaps cyclical destiny. Prepare to have your cosmic perspective thoroughly challenged and hopefully expanded. Are you ready to question everything? So, why does this universe from nothing idea grab scientists? Well, scientists are often searching for elegance, for symmetry. We love theories that are simple yet powerful. The zero-energy concept offers just that. It aligns beautifully with cherished conservation laws. Energy in a closed system should remain constant. What if the universe, the ultimate closed system, and its total energy was always and will always be zero? This idea resonates deeply with our quest for understanding nature's fundamental rules. And it's not just the physicists who are intrigued. Philosophers too find this concept utterly captivating. For millennia, they've wrestled with a profound question: why is there something rather than nothing? It's one of the oldest, deepest mysteries of existence. A zero-energy universe offers a startlingly elegant answer. Perhaps there is something precisely because, in total, it nothing. The universe, a free lunch, so to speak. No cosmic law broken for its grand appearance. This is where science and philosophy beautifully converge. The intellectual appeal is truly magnetic. It's a playground for the curious mind, a concept where rigorous scientific principles shake hands with the most profound philosophical inquiries. It forces us to confront our everyday intuitions, our ingrained belief that something cannot arise from nothing. The universe constantly challenges our limited perspectives, and this idea is one of its greatest challenges yet. But we won't stop at just zero energy. Oh no. In this exploration, we'll dare to go even further. What if this zero-sum game extends beyond energy? Could space itself, and even time, also have negative counterparts, adding up to a grand cosmic total of zero space, zero time? This is where things get truly mind-bending. The universe, a magnificent paradox, appearing as everything yet fundamentally being nothing, a cosmic dance of something and nothing, perfectly balanced. Let's consider the magnificent stuff that fills our universe. All this is matter, a concentrated form of energy, as Einstein showed us with E equals mc squared. This energy is locked within the very fabric of existence. We see this positive energy in light from distant quasars and heat from newborn stars. The scale is immense, almost beyond comprehension. How does something so energetic balance to zero? For every positive entry, there's a negative one, a cosmic yin and yang. The candidate to counteract this immense positivity? Gravity. Let's talk about gravity, the force that holds planets in orbit. Gravity can be thought of as negative energy. Imagine objects attracting each other. This energy debt created by gravity is crucial. For objects bound together by gravity, this energy is negative. Every particle of matter attracts every other particle through gravity. This represents an enormous negative energy, an immense cosmic debt, poised to counteract the positive energy of matter. It has profound implications for the origins of the universe. If the total energy of the universe is zero, the positive energy is offset by the negative energy of gravity. It suggests the universe could have arisen from nothing, a self-creating marvel of balance. We have two colossal cosmic players, positive energy from matter and radiation, and the relentless pull of gravity. Do these titans perfectly balance? If so, the total energy of the universe is exactly zero. This is the zero-energy universe hypothesis. The universe could have sprung from nothingness, supported by observations that our universe appears incredibly flat. Beneath complexity, there might lie an ultimate, beautiful symmetry, a cosmic paradox resolved by zero. Why does the idea of a zero-sum universe resonate so deeply? Beyond physics, there's a philosophical pull. For centuries, thinkers have asked, why is there something rather than nothing at all? The zero-energy universe offers an answer. Perhaps there is something precisely because in total it is nothing. It simply is a perfectly balanced equation. This speaks to a deep human longing for explanations that are both encompassing and elegant. The notion that the universe in its ultimate essence costs nothing is powerful. If the universe is fundamentally nothing, what does that make us? We are the universe's way of experiencing itself, even if its net sum is zero. It satisfies the philosophical need for a first cause, without needing a creator. This ultimate self-sufficiency is what makes the zero-sum universe so philosophically attractive. Our human minds are drawn to symmetry. We find it beautiful. We see it in the delicate wings of a butterfly, in the precise geometry of a snowflake, in the grand, sweeping spiral arms of distant galaxies. Symmetry often hints at deeper underlying principles, a sense of order and harmony in the natural world. So what if the universe itself on the grandest scale possesses the ultimate symmetry, the symmetry of zero, a perfect balance between all that is positive and all that is negative? This isn't just about numbers adding up correctly. It's about a kind of cosmic aesthetic, a profound beauty. Imagine the universe as a magnificent work of art, not one of chaotic excess, but of perfect equilibrium, where every element of something finds its counterpart in nothing. Positive energy mirrored by negative gravitational energy. Perhaps even space and time, as we'll explore later, finding their own balancing opposites. This vision offers a universe that is fundamentally whole, complete, and harmonious. This idea of balance resonates deeply with many philosophical traditions. Think of concepts like yin and yang from Eastern philosophy, the interconnectedness and interdependence of seemingly opposite forces, light and dark, creation and destruction, being and non-being. The zero-energy universe echoes this ancient wisdom. It suggests that the something we perceive is intrinsically linked to a nothing that underpins it all. One cannot exist without the other. They are two sides of the same cosmic coin, forever intertwined. This symmetry provides a powerful sense of cosmic order. In a universe that can often feel chaotic and unpredictable, the idea of an underlying perfect balance is comforting. It suggests that beneath the surface-level complexity, there lies a simple, elegant, and unwavering truth. The universe isn't a random accident, an explosion of arbitrary stuff. Instead, it's a meticulously balanced system, where the sum of all its parts, all its energies, all its being, resolves into a perfect, tranquil, and beautiful zero, a testament to nature's elegance. If the universe truly adds up to nothing, why do we experience so much something? Our senses are flooded with evidence of existence: stars, galaxies, life. The answer lies in the difference between local and global reality. Imagine a calm ocean. The average water level is zero, but waves rise and fall. These waves are like the matter and energy we observe, real but balanced out in the grand total. We live within these cosmic fluctuations, experiencing the something side of the equation. Locally, we feel warmth, gravity, and complexity. Globally, the universe's ledger may still read zero. This duality lets the universe be both everything and nothing at once. It's a magnificent paradox. Local richness, global balance. Our reality is a fleeting crest on a perfectly balanced sea. The universe, in its entirety, is the ultimate paradox, something from nothing. We've explored the zero-energy universe, matter and gravity canceling out. But what if this zero-sum principle extends to space and time themselves? Imagine a cosmos with no net energy, no net space, and no net time. The universe in total could occupy zero volume and experience zero duration. Negative space, what could that mean? not a place to visit but perhaps a mathematical property, balancing positive space. Some theorists suggest exotic geometries or wormholes might hint at such ideas. Maybe for every credit of space, there's a debit of anti-space. The universe as a cosmic accountant, ensuring perfect balance. Reality itself could be a grand sum of opposites, always equaling zero. Let's dive deeper into negative space. If negative space met positive space, would they annihilate, like matter and antimatter? Visualizing negative space is nearly impossible, like imagining a new color. Could it relate to dark energy or exotic matter with negative pressure? Mathematically, physicists can describe negative curvature and extra dimensions. Maybe our universe is just a slice of a higher dimensional reality, where positive and negative spaces sum to zero. The quest to understand negative space isn't just theory, it touches on the universe's origin and fate. If space can be both positive and negative, the universe could truly arise from nothing. No net volume required, just perfect balance. Like the zero-energy hypothesis, it suggests a cosmos of exquisite efficiency. The universe, a masterpiece of balance emerging from the void. We've tackled negative energy and space. Now what about negative time? Could time itself have an anti-duration, balancing the forward flow we experience? Negative time isn't just rewinding the clock, it's a true mirror of duration. Imagine a reality where effects precede causes, or time flows backward. Would entropy decrease, chaos reversing into order? Our arrow of time is tied to entropy, but could a negative epoch exist? If the universe's total time is zero, its entire history is just one side of a balanced equation. Our experience of forward time may be a local phenomenon. Before the Big Bang or after the end, could there be a negative temporal domain? The idea challenges our deepest intuitions about reality. Time, like space and energy, might be part of a cosmic zero-sum. How could negative time fit into real cosmology? Enter the cyclic universe. Some models propose endless cycles of expansion and contraction. During contraction, could the arrow of time reverse, negative time balancing positive? Imagine the universe as a cosmic breath. Expansion, positive time. Contraction, negative time. Each phase undoes the other, resulting in a net zero duration. This symmetry is stunning. A universe that sums to zero energy, space, and time. Existence becomes a fleeting fluctuation in a perfectly balanced cycle. The universe is both eternal and ephemeral, always returning to the void. Our reality, a momentary crest in an infinite balanced dance. The grandest symmetry imaginable, something from nothing forever. Where does negative time fit in the cosmic story? Cyclic universe theories offer a clue. Imagine cosmic history as a circle. Big bangs, expansions, contractions, rebirth. The universe, like a phoenix, rises from its own ashes. Gravity and expansion battle. Eventually, contraction wins, leading to a big crunch. That collapse could spark a new Big Bang, starting the cycle anew. Each cycle might reset the laws of physics or echo the last. Before our Big Bang, there may have been a previous universe's final moments. Time itself could be cyclical, not linear, a cosmic clock endlessly resetting. The universe gains a kind of immortality, not for individuals but for existence itself. Creation and destruction, expansion and contraction, replay in a timeless rhythm. Our universe is one link in an infinite chain, not a solitary event. The cosmic dance is eternal, yet always balanced. In the end, the universe's story is a magnificent loop, forever returning to nothing, forever beginning anew. Let's consider the contracting phase of a cyclic universe. As matter rushes back together, densities and temperatures skyrocket. What happens to time itself under such pressures? Some propose the arrow of time might flip during cosmic collapse. Imagine time flowing backwards, shattered cups reassembling, stars gathering dispersed gas. Entropy would decrease, order arises from chaos. Could this contracting phase be negative time? If expansion is positive time, contraction could be its negative counterpart. The net duration of a complete cosmic cycle could sum to zero. A universe with no net passage of time. Our experience of time's forward flow might be linked to our universe's expansive phase. Perhaps life can only exist within expanding phases. Beyond cyclic universes, what other paths lead to cosmic balance? Consider a mirror universe, a parallel cosmos perhaps existing alongside our own. It might have been born simultaneously with our universe at the Big Bang, endowed with precisely opposite fundamental properties. A perfect, complementary cosmic reflection. This mirror universe could serve as the ultimate cosmic accounting partner. The total sum of both universes would be zero. Zero net energy, spatial volume, and temporal duration. A grand cosmic duet creating something from absolute nothing. This idea is deeply speculative, pushing the boundaries of known physics, arising from the desire for ultimate symmetry and balance. Some suggest our universe was born paired with an anti-universe, traveling in the opposite direction of time. The universe, as a complete entity, remains in a state equivalent to nothingness. This allows for the immense complexity we observe as temporary fluctuations on a fundamental state of nothing. A universe that is simultaneously everything we perceive and ultimately nothing at all. Our universe presents a grand paradox. It appears as an immense, vibrant something, full of galaxies, stars, and the very stuff of life. Yet, its total energy might be zero. This is where perspective comes into play. Think about optical illusions, like the Rubens vase. Do you see faces or a vase? This applies to our understanding of the cosmos. Locally, the universe is undeniably something. But when we zoom out, the universe might reveal a fundamental nothingness. This is the profound paradox that the zero-sum universe presents. The universe plays a magnificent trick. It's a cosmic illusion, teeming with variety. Yet it could be absolutely nothing. This might be a fundamental feature of reality. The universe, in its wisdom, is both. This something from nothing is incredibly powerful. For the scientist, it upholds conservation laws. For the philosopher, why is there something rather than nothing? Perhaps because something on the grandest scale is nothing. Embracing this paradox can foster a deep sense of wonder. The universe is far more intricate than we believe. It's a realm where contradictory ideas can coexist. It can be both, a magnificent dance. It's a characteristic to be marveled at. We've journeyed far, exploring a universe that might be nothing, a cosmos that balances out with breathtaking precision to a beautiful zero. This universe, born from nothing, seems like a contradiction. How can so much stuff be no stuff at all? What if this paradox is a profound feature of reality? The universe can be its own magnificent cause. This paints a picture of ultimate cosmic unity. Positive energy finds its perfect negative gravitational counterpart. Everything is profoundly interconnected, part of a grand, unified design, astonishingly simple in its fundamental totality, the silent, resonant music of zero. And what about the philosopher, the relentless seeker of meaning and truth? This vision of a zero-sum universe offers a deep, resonating solace. Why is there something, rather than absolutely nothing at all? Perhaps the answer has been subtly, elegantly staring us in the face all along. There is something precisely because, in its grand total, it is nothing. The universe, a magnificent, almost unbelievable cosmic free lunch, so to speak. We are the universe's unique, incredible way of knowing itself, of reflecting upon its own majesty. Our lives, our consciousness, become a vibrant testament to the universe's incredible creative power. It serves as a profound invitation for us to keep questioning, to keep exploring. So as we gaze up at the star-dusted velvet canopy of the night sky, let us pause and remember the universe's magnificent, deeply paradoxical nature.